see you on the live stream if I am seeing you, and thanks so much for coming down to the Muse Hub Hackathon. I'm David. I've been the creator of Muse Hub. We worked on it since March last year, and the goal is really to just bring you a springboard or a launch pad where you can build your product the way that you see fit, and then monetize it or bring it to an audience through the Muse Hub pretty quickly. The goal for us is to get from code to product in 10 minutes. We're not always there yet, but we want to make it very, very simple and straightforward. So super excited, and thanks to JB for organizing this hackathon. The turnout has been great, and we hope to run more of these in the future as well, so do watch out for further and future announcements. So I'm not going to drone on very much. I mean, we'll do a Q&A about Muse Hub afterwards if you've got questions for me specifically. But without further ado, I want to introduce the Klangio guys. Alex and Sebastian are going to talk about Music Transcription Studio.
So, yes, we are Alex and Sebastian. We are from Team Klangio. We came the way from Germany here to London for the Muse Hub Hackathon to do something with our web-based apps that we develop for music transcription. Actually, we wanted to push them into the Muse Hub store. So, what is music transcription? Music transcription is the magic of converting audio into written sheet music. So you put some audio in our apps and you get sheet music. So that's a problem that we're trying to solve. And yeah, we first tried it out with piano music, and here I have some example Despacito Crazy Latin cover by Johnny May. Let's have a listen. So we built an app for piano transcription called Piano to Notes. It is based on Electron and a web-based wrapper around the Klangio API that's available online. And here I have the MP3 file of the Despacito cover, and I just drag and drop it into the app. Here I can select which instrument I want to transcribe. I select piano. In this case, it's a solo recording. I would like to see pedal markings in my sheet music. It's more of a pop song, and I want to do Klangio to recognize the rest. So I add the title and the author and can start my transcription. Now it's uploaded into our cloud where our AI transcriber lives, and that one listens to the audio file and tries to figure out all the notes that were played, figure out the rhythm, and creates a sheet music within seconds. So let's have a listen to the result. That's quite cool, but what's even cooler than transcribing piano? Transcribing guitar. So we also built a guitar transcription app called Guitar to Taps. And here I have a quite cool cover song by Mike Dawes. It's a fingerstyle song on acoustic guitar. It's a solo recording using finger picking, drop D tuning, and no capo was used. So just the same stuff here. Now this one is analyzed by our AI too, and within a few seconds we should get our sheet music. But we don't only get sheet music, we also get tablatures. So if you can't read sheet music, it's something for you too. And that was the generated sound. We can also have a listen to the original. 1, 2, 3, 4. And it picks it up very good. So what's even cooler than transcribing piano or guitar? Transcribing the whole band. So we also built a third app, the Music Transcription Studio, where you can upload an MP3 file with a full song. Here I have a cover of Streets of London by Rebecca Jane. I can select which instruments should be transcribed, but if I don't know which instruments are in the recording, I can just let them be detected. In this case, it's a multiple instruments recording. I enter the author and start my transcription. So let's have a listen to the original first. It's with the guitar.
Have you seen the old man?
And if we go to the app, it is still processing. It takes a little bit longer, but here we have our transcription. And as we see, we have a full score with several stems. It begins with the guitar part. I jump forward to the beginning with the singing, and I play the playback. It's a little bit low volume, but you can guess what it does. We also get the lyrics of the song, and the best thing is we can download the result as PDF, MIDI, Music XML, or Lillipond, and we can download, for example, the digital score as Music XML, and then open it in our favorite sheet music editor, which is, of course, MuseScore. And then we can do a lot of amazing stuff with the music. So that's us. We pushed our betas to the Muse Hub store, and we are hopefully going to launch the apps by next week. Thanks for your time. Thanks for having us.
That's great. That's incredible work, actually. Has anyone got any questions for the Klangio guys? No questions? I'm talking, no questions. No questions, guys. I'm sure there are lots of questions, but we'll move on. Thank you so much. That's really, really cool. All right, I think next up, if we get back to the list of apps. Audio Spectrum Analyzer. I can sort of guess what that might do. Are you doing the speaking?
Team might start.
Sure.
Talk to them when it's set up.
Of course. Can I quiz you about what your stack is? What did you choose to write this one in?
CMajor.
In CMajor, fantastic.
CMajor. No experience.
Starting from scratch before today, nothing with CMajor. How did you find it?
We got something.
Yeah.
As you can see. Something are not entirely polished, I think, to be honest.
Okay.
It's getting there.
Yeah. But that's fantastic to go from nothing to a new framework, to a new language, to a product that you're now about to demo in front of a bunch of developers. No pressure. In 24 hours, that's phenomenal. All right, thank you so much.
Thank you. So let's start. I have an incredible opportunity to work with Johan. I met him here during the hackathon, and we decided to build an audio spectrum analyzer. So the short inspiration, just like what if you can DJ with code, okay? And where you can do that in the future, like online, using the browser, right? To collaborate with someone. And how to identify what you are playing in the browser. Like the solution is built in audio spectrum analyzer. And now it's your turn.
So yeah, it's what can I say? It's a audio spectrum analyzer, but it happens to be our audio spectrum analyzer. Does what you expect, or at least the basics. So kind of immediate response to the input, and then some peaks.
It's how our process looks like. We use VS Code, and we use CMajor extension to debug and to run and to develop our plugin. This is the node like architecture. How it's called?
Graph.
The graph. Sorry, this is the graph. How on the backend node connected to each other. And now it's showtime. Okay, so what we see here, could you please explain a little bit?
Yeah, fairly basic incoming audio real-time Fourier transform the latest frame, and then on top, kind of the peaks over actually configurable.
Yeah, I'll go to this one.
Yeah. So more or less memory, so slower to respond to the input.
And go to the right.
Less memory, so moving in sync with the input.
And window type.
And then some basic windowing options. That's it.
Yeah, thank you.
It's a great job, guys. And that's, how many hours is that? 10?
Normal amount of sleep.
Yeah.
10,
Maximum.
noon to 6, 10 to now.
Yeah, fantastic work.
Yeah.
Yeah.
The map and
Wonderful, thank you so much. Okay, and next up we have Windchime. Fantastic, please come on up, Windchime.
Sorry, delay makes it really hard to understand.
Yeah, I guess turn it down while I'm speaking and then just, yeah. Cool. You printing that? That's the microphone for you, it's just for the live stream.
Cool, cheers. Yeah.
All right.
Oh, although, do you want to connect for now?
If it will work on mine. Ah, yeah. It's not. I mean, I've got this software. I know it's not the latest. It depends.
I mean, I can.
Okay.
It should be easy enough to swap round
You
if
think-
you just go through the.
You can indicate to
Yeah.
get in the software. Okay, cool. That's an interesting colour.
Cool. Nice.
Hello. Hi, we're Ollie and John, and we met here yesterday, and we both had an interest around doing something with data sonification. We're both not really audio programmers, but we've done some Max MSP and some pure data, and we both got to the situation where we've got these patches that are quite confusing and time-consuming to work with, and not too intuitive to do data sonification with. So we wanted to make something that was quick, intuitive, and inspiring as a composition tool to work with local data, and we decided to choose Windata to focus on. And so for our solution, what we ended up doing was using Blender to create simple UI animation, bringing that into C++ with Juice, and using timer, bringing in some wind data via an API, and then using that to control internal MIDI and parameters. And I guess we'll go to a quick demo now.
Yeah, sure. Yes. Cool, yeah. Is that sound working? There should be a little bit of sound coming out. Cool. So yeah, it's a very simple UI at the moment, but we have a, currently it's just a simple way of the user being able to pick from a set number of locations, and it just feeds back a sort of basic wind chime sound at the moment. So this is London. It's not particularly windy at the moment, but according to some website that I found online, Balta Sound in Scotland is much windier at the moment. And so it is reflected in a sort of intuitive way through So it takes the wind speed and it uses that to control.
You're not sending sound
Oh no.
to us.
Oh,
Yes, here we go.
yes, that should be better. Is that working?
No, I don't get any sound yet. No. It's a mic output.
Yeah. I'm not sure. Yeah. I'm not sure because yeah, it was working through the MacBook output.
Yeah, we're getting it through the laptop speaker.
Okay, well, let's use the speakers.
Yeah, sure. Yeah, sorry about that. But yeah, so it uses the wind speed to sort of simulate what it would like sort of wind gusts. So it uses it to control various LFOs that modulate each other to swell up like currently sort of speed of an arpeggio basically in a way that reflects real world wind. It uses the wind direction to change some other parameters in the synthesis in Juice. And the idea is that it would be, this is kind of a proof of concept, but that hypothetically it would be a MIDI plugin that would read your current location data, and then it would output MIDI data, which you could then like build your own compositions on and use it, because like obviously data sonification is a really exciting and very intuitive way of just changing up your workflow a little bit when you're composing. And so to just be able to drag in something that's going to be new every day, and depending on where you are, get MIDI data from that and then build compositions from that. Yeah, that's the idea of it.
Yeah, thanks. So yeah, as we said, next steps, user-defined location, bringing out some of these parameters, making them more controllable. At the moment, we're not interacting directly with the WebGL UI, so we want to kind of re-implement that so it becomes an interactive element. And yeah, work with that user input to make it more creative and collaborative, and also yeah, MIDI output. Thanks.
Great, well done, chaps. Thank you so much. Super cool idea, using wind data, and that's great. Yeah, what's your step there? Okay, next up we have Ambi4. Very good. All right. There you guys, good to see you. Did you guys know each other before this? Yeah, you worked together before. You all study here? Yeah. Oh, fantastic. Great. All right. Which year are you in? How long have you been studying for here?
Well, we're all on 1 year masters.
Okay.
So, yeah, only just got here really.
Fantastic. And the name of this one is?
Ambi4.
Fantastic.
Oh, yeah, I'll take it.
To you. Thanks so much.
Yeah, so we are, I'll just get this slides up actually. We are John, Joe, Laurie and Spencer. Well, I'm Laurie. I'm John, Joe and Spencer, who had to leave early unfortunately. Yeah, we're all, as we said, we're all students here at Queen Mary doing sound and music computing, which is a 1 year master's course. We decided to make this plugin Ambi4, which is a sort of a granular effect which listens to your history as you play that audio through it, and then randomly samples grains from that history and plays it back. We kind of came into this just not really knowing at all what we were going to do, and then decided, you know, roughly about 2 p.m. yesterday-ish that was a good idea. So it's been quite a lot of work to get it there. We use Juice completely, and I think a few of us had some experience with Juice before, and we wanted to get up and running quite quickly. So yeah, that's that, do you want to say anything else? I'll do a bit of a demo as well. So I've got a session here. We've got this synth part. Actually, I'll just see if I can get audio out. Are we getting any audio? Yeah, it seems to be. Yeah, we're getting. Yeah. Anyway, that is. We have a synth part here, and it is not really going to have the same effect if I try and describe it, but it's kind of a bit sparse, so it kind of feels like it might need a bit more movement. So what I did was route that through a reverb and then added this granular effect on it. And what that does is it listens to the history and then adds just a bit more movement, a bit of texture, and kind of really has this like beefy background sound to the track. It's a shame we can't hear it, but yeah, I hope that's yeah. I mean, you'd have to come and download it on Muse Hub yourselves to actually try it out. We hope to complete this. It's not really in a releasable state yet. We hope to complete it within the next few days, maybe a couple of weeks, and then get it up there. But yeah, thank you. Any questions?
Could you maybe play a little bit out of your MacBook?
Maybe, yeah.
Yeah, we go old school.
The next presentation is a footstep generator.
So if I... I've missed the routing. There you go. So yeah, you can imagine when that's mixed correctly, it kind of adds this nice, nice background.
Fix it in post. Yes, cool. That's great. That's well done. Thank you, guys. Great. So the next one is heel-toe footstep generator. Thanks, guys.
Guys, if you have HDMI on your laptop, plug that directly, not the USB-C, because
yes.
that way you will get audio as well.
Go for HDMI if you can. Had you guys worked together before? Or are you? No. Together for the hackathon?
Yeah.
Oh, great. Fantastic.
Let's see, trying to connect. See it here? Can you see it?
Yeah. Okie dokie. Who's doing the main presentation? All right. Thank you.
Hello. Okay. All right, everyone. Thank you. It's been a wonderful weekend. I'm Alex. I'm a sound designer, and I've worked together with George to develop the heel-toe, a rapid footstep generator for sound designers. And so this is inspired by my own professional work as a sound designer for films and games. And so we decided to design an application that would we would separate the heel and the toe recordings from a footstep and use those to randomly select a heel and a toe recording to create a new footstep using a very small amount of original audio. And we pass that through an effect chain with reverb and pitch shift, and we'll show you some of these things in a moment. And it would allow us to easily create seemingly endless possibilities of different footsteps with a very small amount of original recording data. So I'll pass over to George to talk a little bit about how we built it.
So implementation-wise, it's a Python 3.10 project. It uses 3 libraries to make it all work together. We have PyDub, which takes the 2 sound bites, one of the heel, one of the toe, randomly stitches it together, And on the diagram there, that's the output of stage 1. Stage 2, that's the stage which applies the effects chain. We wanted to let the user have access to controlling it so that they could adjust the reverb, adjust the pitch. And the output is a saved file of the whole thing. Demo?
Yeah, demo time.
Demo time. So let's see if the audio works for this. This is the demo for the low-pass filter setting. This is generation without an effect, but yeah, I think we don't have audio here either.
Can you double check the driver?
Yes. One moment. There we go. Sorry, let me play from the start. Yeah.
Sounds like it's coming just through the live stream, but you can imagine it with a low-pass filter.
Yeah, so each of these controls in the UI, they would allow the user to select a setting, adjust it. If they don't want the setting to be there, they have the option to remove the check from the checkbox.
Mm-hmm. Cool. And so kind of what inspired us to make this? Well, it's something, as we've shown, you can rapidly create multiple different kinds of footsteps and save lots of time on recording and editing, lots of possibilities. And if you mess around, especially with the low pass and the reverb settings, you can create footsteps in a variety of different physical spaces. So feature development, so we would hope to continue working on this and actually develop it further as a video game plugin for something like Godot or Unreal. So it would allow developers to basically have for their characters create unique footsteps in real time, which would be fantastic, but particularly for like independent or mobile game developers who need to be very aware of the file size restraints that they have for their projects. And thank you very much.
Well done, chaps. Thank you. Thank you. I assume you could put in some different combos and get other things like hand claps or whatever.
Yeah, and we also did have the idea of potentially creating some effect chains, like predefined effect chains. So something for a big room, small room, maybe even try something more advanced like gravel, but yeah. We just didn't get the time for it.
A Foley dream. Wonderful. Who's next? Shrudio. Excellent. Yeah, if the Shrudio guys want to come up. Just for my own interest, by way of hands, how many of you are working on apps versus plugins? So would you consider your project an app if you just raise your hand? Okay. And how many would you consider a plugin, like a traditional plugin? It's actually a pretty even split. Okay, 50-50. Very cool. All right. Yeah, Shrudio, if they're around.
Shrudio's not around.
Shrudio's not around?
Yeah.
Oh, they're in there. I can see a little hand. Is Shrudio in there? That is cutting it fine, I have to say. If this were Bake Off, I would be... if I was Paul Hollywood. Should we switch the order up a little bit?
Collider is the next one.
Switch.
Collider.
Collider. Fantastic. Please come on up. Great. And if you just want to pop into the HDMI port there. Have you chaps worked together before?
Yeah, not as a 3, but
Yeah.
as a 2 and a 2.
Excellent.
So first.
Excellent. All right, Collider. Shall I hand you the mic?
Yes, please. Thanks.
Try this. See if it works.
All right. Yep. Came through. Yeah. Yeah. Fine. Is that all pink? Or okay, that's fine. Hi everyone, my name is Will, this is Leon, and this is Micah, and today I'll be presenting Collider. So what is Collider? It is a chaotic physics-based delay plugin built using C++ and Juice, really for producers who want a unique kind of a creative way of putting delay into their mixes. What you can use it for is something like making rainfall-like meditative ambience with synths, ridiculously complex drum patterns, and randomized stereo stuttering for vocal tracks. So how does it work? What you have is a world here. It's a 2D world where you can create particles by putting emitters into the world. Collisions with particles and walls cause delay taps, which are panned depending on the location of these collisions. What you can change at the moment is emission rate, particle lifetime, particle speed, and the wet delay level. And you can also drag and reshape the world to kind of push the particles around and to kind of cause different collisions to happen. So Mike is going to give you a quick demo here of how it works.
Cool, yeah. I don't know how well you're going to be able to hear it, but so what we do is you start by adding an emitter, and then you can change the parameters, kind of change how fast they're going, how long the balls last. So I don't really know if you can how well you can hear it.
That's fine.
And yeah, so then you can basically just add a lot, add loads of balls, make the rate really fast. And then, yeah, you can also like resize the UI and the balls kind of interact and collide, and they get panned based on where they collide. And yeah, you can just kind of mess around with it.
Try pushing the balls.
Yeah. Yeah.
That's it. Thanks very much.
That's great. Really cool. And who did most of the UI work there?
There's a bit on everyone.
Yeah, really cool. Like how it changed color based on the rate and everything. Very cool.
Yeah.
All right. Thanks very much. So Shrudio, are those guys, are they out of the room yet? Shrudio? No, I think they've disappeared as well, so we'll move on to the next one. Okay. Next up is Gamified audio training for hearing rehabilitation. Thanks very much. I can also have a guess at what this does as well. Good to name things literally. All right. Hand you the microphone. Thanks very much. Very cool. Thank you.
Hello? Yeah. So I have come up with the idea of gamified auditory training for hearing rehabilitation. So my target audience is, the images are not loaded, parents or the one who has hearing aid, who are hearing aid users, elderly people, and the people who are like trying to adjust to the surroundings, who had just got their ear operation and all. So, or anyone who just wants to have fun with the games. And the games which I have designed are guessing the sound, reaction time, auditory memory game, track the speech in the noise, rhythm training, and 3D sound guess. In the guess the sound, there will be an audio played. This is a very simple game, and you have to guess which animal or what it is, like thunder and police siren. Reaction time is there will be noise, so that the hearing aid user identifies somebody's voice in the noise. So this is what is there in the track the speed in the noise one. In auditory memory game, there will be some words or something said in a go, and the user will have to listen to it, and then there will be some question like which was said first and all. In 3D sound guess game, this is especially focused on the specialization, sound specialization. The user should know like which direction the sound is coming from. In rhythm training, there will be some some beats, 4x4, 3x4, and the user will have to tap by understanding the beats, rhythm. I think I skipped reaction time. In reaction time, there will be a noise, and in the middle of the noise, there will be one sound like, for example, popping of a balloon. And the user will have to react to it as soon as possible. That the time will be judged, and as per that, it will be there will be a result for that. And this is the app APK, and I have the app GitHub. This is not loaded, and the challenges that I faced in this was first of all like time, and the 3D audio part. I wish if I got more time, like I could have been more clearer with that, and I did not get properly test it. This is from where it started, and I don't know, it's not loaded. So I have this app downloaded loaded on my phone, and I use Flutter for that. And yeah, these are all the apps, and y'all can try it. Okay, yeah. Thank you.
Thank you very much. And how many separate apps are there or separate functions?
It's just one app, and all the games are in there.
How many separate games?
There are total 6.
6.
I tried
Right.
10, but it came out.
Yeah, well, 6 that's fantastic. Well done. Okay, next up is RelaxSync, which sounds very relaxing, I have to say. Yeah. Thank you. Did you guys know each other before, or you just formed a team for the hackathon? Yeah. Very cool. Best friends for life?
Yep.
Hey, that's what we like to hear. All right, do you have a HDMI port on the MacBook there? No, there's adapters. Yeah, if you want to pop the adapter in, and then that should do it. Might want to give it a. Might want to try one of the other ports actually, because not all of them are. as going to the HDMI. Yeah.
Here's an Apple branded one. Maybe try that.
Yeah, I think. Got to pay the right amount of tax.
Yeah.
What do you reckon? Maybe a laptop they could borrow, or maybe a laptop they could borrow, maybe? Yeah.
Would you have another laptop that you can try this on?
Yeah, that's what we're doing. Because the laptop just emerging the connector.
I think we're going to ask the next one. And try to fix it maybe on another laptop, and then you come back.
Yeah, should we try to switch the laptop and then...
No, that's the one.
Oh, there you go.
Yes.
Well done.
Yeah.
Well done. Stress over. It's all good. Who wants to do the talk here?
Yeah, I think we'll
We'll do it? Okay, I'll give it to you first.
Thanks very much, guys.
I don't know if there's audio. Hopefully we have some audio.
Good to start. Hi everyone. We are here to introduce RelaxSync. It's an app that tracks your heart rate and adapts music in real time to provide a more immersive meditation experience. We all know when we are stressed and anxious, we have a heart rate up, especially when you are experiencing something like panic attack. All the existing meditation apps out there provide static music that really doesn't adapt to how users feel or the current mood state. Here at RelaxSync, we use your physiological markers like heart rate to adapt music real time and therefore provide more calming music during meditation. Here, the emphasis is on adaptive music that transitions real time by adding different layers to your music or changing tempo, your tonality, etc., in order to make sure there are no jarring effects in that experience.
Meet our MVP user, Jake. So you can see how he feels before the session, during, and after the session. So before the session, he feels overwhelmed and he can't focus at work. So he tries to use this app to relax himself. And during the session, he thinks this music adapts perfectly to how he feels. And he feels his stress was reduced. And after the session, he feels energized, relaxed, and ready to tackle his next task.
Right, so let's get into the demo. So yeah, here you can see that Jake, who is our use case or user persona, he is stressed, he comes to the app, and he is wearing a heart rate monitor that tracks his heart rate and sends the data to the app. So here on top, you can see the heart rate, how it is performing. So we can assume that Jake, who is stressed, is pretty much at a high stressed state. Here, for example, here we are manually changing it, but ideally in the real world, it's going to be tracking directly from your wearable device. So you can see how the music is at this moment, and as he is meditating and his stress level changes from high to low, high, medium, and low, we can see how the music adapts automatically without creating any disruption in the experience. Like,
So in this demonstration, we have the heart rate visual at the top there, and then we have some representation of the music down below. So when Jake gets a little bit more stressed again, sorry Jake, we have a pre-composed set of tracks that that we're currently layering to kind of simulate the music adapting to Jake's state in a way that's hopefully going to bring his heart rate down. So like in this model right now, we've got the Jake state affecting the music, but we don't quite have the music relaying back to Jake. So hopefully, he gets more stressed. The music, you can see we have a color gradient, red meaning more intense, so calm down intensely, Jake. And hopefully, hopefully Jake will come back down to rest, yeah? And so this is a demonstration of the kind of concept we're coming with. Yeah, okay.
Okay, so basically the technology underlying is we take the input of the users, and the input could be different according to the tasks. So the input could be the heart rate and pacing if you are exercising, and it could be the avatar's health if you are playing a game. So then the music adapts to input in terms of rhythm, tonality, dynamics, and timbres. And the adaptive algorithm could be rule-based or a hybrid of machine learning methods.
So here you can see how this technology can be used in different scenarios, and this is not just in the concept of meditation. So for example, if someone is exercising, as we all have experience when you're warming up, you prefer more subtle music that helps you motivate you. And as your heart rate increases, as you increase your intensity, you would want a little bit more faster music, intense music that's again going to motivate you. So we're building something that is going to adapt based on your heart rate data, and again on different concept, which is gaming, where as you go through the experience of gaming, probably when you enter into the gaming, we probably want an intro music, which is going to be calmer, but as like you see attacks and defending happening, we want more intense music. How can that be adapted based on certain inputs, again, without like creating a disruptive experience?
So actually we made Saxon made another set of tracks, and these are kind of to show I guess, not just the relaxing music. I thought this music was quite nice.
So you can see how the layers are being added one on top of the other.
I think if you listen out, you hear, yeah. And I guess, the point is that we kind of want to control the music in such a way that the user can have their state kind of affected by the music, yeah? So we get a feedback loop between the user and the activity, and the music responding to hopefully encourage them to achieve their goal, be it exercise, focus, work, or anything really in that sense. So.
Cool. Thank you.
I guess we're not doing Q&A.
That's very, very cool, guys. So that uses stems. It's sort of like it's kind of fading between stems as your heart rate.
So we've got a set of like people motion patterns.
Yeah.
We basically layer them based on the state. So within certain heart rate bands, we add more layers to kind of emulate them. If I'm really stressed, more layers.
Absolutely.
That's the concept.
Very, very cool. Well done. Thank you so much. Really cool. Okay. All right, next up we have Tape Loop. The Tape Loop guys are around. Oh, okay, fantastic. Thanks very much. That's good. And are you guys, are you studying at QML? Are you know each other already? Yeah. Lovely. Great. All right, shall I give you the microphone? Thanks very much.
哎呀，我操！这个怎么同时？可以直接打开网页，就这样。So this is our app, and hello. Okay. So we designed an iOS app, and it is a recorder, so you can record the audio and play the audio, and when you record during the playback, the new recording will rewrite the previous audio. I think this idea is similar to the real analog tape loop. So for tape, you can rewrite the original sound in the tape, and you can adjust the speed of the tape. So here, I will show you how it works. Okay. Hello, hello. No sound. Let me try my computer. Hello, hello.
We can use the mobile phone.
Wait a minute. Let me try. Hello, hello. Hello, hello. Yeah, you can hear from my computer, I think. Yeah. Hello, hello. Hello, hello. Hello. La la la. Hello, hello. La la la. Yeah. Hello, hello. La la la. And you can also adjust the speed. Hey, hey. Hey, hey. Yeah, and for this hey, hey, also it is at a higher playing speed. But for real tape, if you play at the speed of 2 times and you record, then you play back, then the sound sounds like your original speaking, which means also I'm playing at the 2 times speed, but this hey hey is not speeded up. So hey, hey. And when you slow it down. Hello, hello. Hey, hey. Oh, this hey hey will be lower. Hello, hello. Hey, hey. And hello, hello. 1, 2, 3. No. 1, 2, 3. Yeah. Hey, hey. Hey, hey. Yeah, so it's just a playful tool to interact with sound and an experimental way to play with the sound to create interesting sound textures. Yeah, and for the implementation, the app is developed mostly in Swift. Both the UI and the audio manager is implemented in Swift. But for Swift, it's difficult to handle the low-level audio buffer and these things. So the audio buffer is written in C++ and then bridged to Swift. And yeah, yeah. So for future functions, we will support the save and download the recording to your phone locally, so that you can share the recordings with other people. And yeah, here's a website we built for our app, and this is the name is called passaco.world. And if you click this, say hi to us, then we will. You can send your email to us, and then we can add you to the to the iOS App Store test flight, and we can. And if you download test flight on your phone, then you can download this app currently. Before we launch it to the iOS App Store, you can first download the app internally through this internal test group. So Can I just bump in and have a few words? So our studio is called Passacle, and it's an idea came out a few months ago. And what we want to do is like, we're going to craft a more like Pokemon Go, like that kind of world, and we are inspired from Tamagotchi. So it's like, this app is actually called, current name is called Memo Loop, because it actually connect your own world, your own life into this recorder, and you can make it very portable to go outside and interact with your surroundings and get your memory, just like taking a picture or taking a video. So this is our branding. So like what we are doing in the future is like we're gonna develop more apps that's involving sound mechanics inside and make people more want to go outdoor and really interact with the surroundings or other people, to change the social states of themselves, and just, you know, because of COVID and many people, they just get locked down in the house, and it's really, I think many people, they realized how hard it is just to disconnect yourself from other people. So I think it will be also a good idea to maybe like in a gamification way to just let people go outside and have more fun in a different ways, rather than just staring at the phone for the whole time. Like usually when I test this app, I just sit in the underground and enjoy how I spend the time with my phone, but not staring at it for the whole time. So I think it's very meaningful for us. Yes, that's for the Passacle. So it's like a little bit promotion for our studio, and hope you like our idea, and looking forward to hearing from you. Thank you.
JamSync, thanks so much. We're picking that up. There you go.
So hi everyone, I'm James, this is Sammy. Neither of us have a kind of musical or audio technical background, so we decided to focus on the social aspects of music creation. So this is JamSync. It's a collaborative music platform for people wanting to create a jam session online. So users can come onto the platform. They can, who want to create a jam, they can choose the genre, whatever that they want to create it in. Maybe they want to do an original piece or do a cover. They create a jam. It takes them through to the jam studio. In the jam studio, they can record their track, which forms the starting point of the jam, whether that be vocals or drum beat or whatever it be. Once they're happy with that, they save that. That becomes a jam. Other users can come onto the platform. They can search by genre of whatever they like or the title. Then they can, once they're happy with the search results, they can preview the jam, see what the original track which created it. If they like the sound of it and they want to contribute to it, press on collaborate, and then they go through to the jam studio where they can listen to how far along the jam has evolved with all the different people who've contributed to it so far. And then they can play it back and record their section of whatever they want to contribute. Then that forms the jam. We think this is kind of particularly good for people, maybe they want to join a band, but there's no access to it in their area, or maybe they're just starting out and they're not quite sure on the timing of when to join in on a live band session, or worried about making a mistake. This is kind of a low-risk environment for them to just practice around, do as many takes as they want, and when they're happy with the take, then they can upload it. So I'm going to pass you over now to Sammy. He's going to explain creating a new jam session, previewing, and contributing to an existing jam.
Yeah. Thanks, James. Yeah, so if you want to create a new jam, it's pretty easy. Just say, my jam. I don't know why the colors have gone weird. Pop, the key, and the BPM. You can input it all in. Creates a new jam. And like James said, if you want to pre-just say, go. Get any volume. So you can see that's like the first jam that started off this session. If you want to go in and collaborate, you can go in and see all the different clips that other users have uploaded. So you start. You can
not musicians.
You can decide which one. And then of course you can record as well. Your one's like bam bam boop bap boop boop. And then you can play them all together. Because then you can upload that where we've used Firebase to store all these. And that's it. Then you can see your new clip and you're ready to go again and keep adding and having more people collaborate and join your jam sesh. That's it? Yeah. Anything else? Yeah. That's it.
Well then, guys, that's super cool. Cool song as well, like it. Thanks very much. All right, next up is DAW XR. Hey, guys. Hi.
The HDMI. This one is not going to the live stream. Okay, so we need to do this video.
That's it, yeah. You got it. You want to do some of the talking?
I can do talk and we'll pass it on.
Sure.
Just hold on a second. Yeah. Cool. Can people see it? Okay, cool. Hi, we are DAW XR or XR DAW. Charles, Connect, Kevin, Devin, and Dan. We really want to build a kind of a revolutionary, again, this is not my word, AI-generated, groundbreaking web browser-based and actually mixed reality-based digital audio workstation. It all started with, it's a bit small, then the idea on the message board, and that's how we get started. We really want to make music creation pervasive, not by the expert, but by anyone. And also in a very different way, not kind of the professional, the music sheet as well as DAW interface, and more importantly, immersive. So maybe quickly. This is what we built. We'll go to the site to explain what this is all about. So first of all, because this is the virtual reality AR reality glass interface, but this is a web browser. So it's simulated. Normally you do have two controllers to interact with the also, you can see through the spatial, your environment, your room. So what we did was load the music, MIDI, into this 3D space. And again, unfortunately, we don't have glasses that you can play with, but it's a mixed reality. You can put this new format of music onto, for example, a table. And the different music will display different shape and style. Let me quickly explain a little bit. So this is a timeline. Each note from the MIDI will have the duration, because if we put the duration along the timeline, it would be too long. So the duration is actually z-axis. And also the velocity, the strength of each note is a vertical line. Duration, and the different color for now, we just use the color to explain to showcase the pitch. And here, as I said, you have two physical controller to interact with this kind of 3D objects. But you can replace in the software the controller to be something else. For now, we just loaded Meta, the 3D GAN model, but you can load an instrument. So to interact with the new format or 3D format, for example, to change or interactive with. So let me quickly, again, this is a simulator, because once you have that glasses on, watching this web XR enabled, basically pretty much all the modern browsers has this XR, web XR standard. So then it's really fast. And also, as I said, it's a mixed reality. Once you put this kind of a 3D object in the physical world, you can equal loom. If you notice the corner, it's kind of a loom scale movement. Basically, you can walk towards or across your different music sitting in the virtual world. Something like this. Did you see? I'm walking towards this. This is my head. I can walk around, and the controller can interact with the new format of music. This is, you can walk around the timeline of your music. Because, yeah, the simulation is a bit slow. The mouse is very fast, but the keyboard is a bit slow. Any more you guys to add before we switch to the functionality?
You don't play sound, right?
So sound is actually not working.
Oh, it is working.
Really? Sound should be there, right? How to play sound? Actually, yeah, okay, fine. So anyway, so what we did is, as you just saw, we have the 3D and 4D. 4D is a timeline, because if you start playing, you can, it can be animated. It's a 4D interface. And also, it's clearly browser-based, but also XR ready, web XR ready. We are working on the interactive editing. Basically, it's a raycaster that while you are moving your controller, you have a directional as well as a distance. So you can interact with your pictures we loaded into the virtual world. And the technology stack is the React 3 Fiber around the 3JS, and the React 3 XR, which is a wrapper around the Web XR standard. Then, thanks to the live collection of audio, we use Web Audio API. So, yeah, the learning curve for us is really sharp, because it's just layers of layers and a new framework. And also it's React is functional programming, but this time we need a very extensive interaction. So from various functions, we need to access the objects, the instance. So it's actually a lot of challenge. And also collision detection, basically the interactive stuff. Unfortunately, yeah, we have some bug, but we're getting there. So all in all, it's a functional prototype, and it's cutting-edge compatibility. We are very proud of that, because the Android XR announced 3 days ago by Google and Samsung, it does support, basically it's a Web XR standard, meaning the stuff we're building can be easily accessible by the new Android-based XR glasses coming soon. And of course, we learned a lot of stuff, skill acquisition. Future roadmap is definitely enhanced interactive interactions, which we actually have some working code, but just too buggy to demonstrate. And also, you noticed it's at the moment it's really good for XR. If you have a Meta Quest 3 glass, but web interface is still a bit kind of not natural. So we want to support a natural web interface as well. And also, because it's web technology, all the C++ plugins, so if you recompile it using encryption, so you can have a web assembly, meaning we can access these plugins as well. Of course, an AI, because so during the interaction, you can play, select a different chunk of sections or track, then apply transformation. And also, again, because of the web technology, we can easily use WebSocket to enable multiple interacting with the music, or multiple team editing different soundtrack, putting in a virtual room setup, or in a collaborative way. So it's open source, thanks to then a lot of collection from him. And we also found it's not just for kind of editing as a kind of a DAW functionality, but it has a healthcare use case as well. For example, for elderly people, right? So this can be a tool, load their favorite music, and they can interact with it for cognition stimulation. So this kind of a healthcare use case as well. So anyway, so that's it. Anything to add?
Yeah, one thing I'd like to add as well is for musicians, it does support MIDI out, so you can obviously connect that up with your synths and everything. So that's just
this is the MIDI file in the 3D world, as well as so the timeline 4D. So yeah, once you edit it, you still can have an exact copy of your MIDI file. At the moment, we're using Zen's collection, but we can also use Tone.js. We do have another code we haven't checked in. It's a Tone.js based. So yeah, that's it. Thank you.
Great job, guys. That's very cool. It becomes really interesting when you start to think about different dimensions of being able to access sound through different dimensions. It'd be really interesting to see where the augmented reality space goes and the virtual reality space as these devices get easier to buy and to consume things from. So, Chord Explorer is next. Looking forward to seeing what you guys have been up to. Thanks, guys. Watch you sit there.
Well, after it, all right.
Yeah, I can take it. I think I should use.
Slides.
Okay. Is this HDMI working? Actually.
The audio is not working.
Yeah, but I didn't use a dock, so I don't know. Okay, so we are trying to solve this problem of altered chords. Our target users are mainly jazz players, and in jazz, many chords are like this. There are alterations, 7ths, 13ths, 6ths, and it's hard to learn them, and it's also hard to practice them. So we offer two types of practice scenarios. One of them is you can just explore the chords without any physical inputs. So you just have your mouse and you are exploring different alterations in different key signatures, and you can choose the like you can transpose it and then experiment it both like you can hear it and then you can change the order and create a chord progression. So the second part is when you try to compose a song, let's say, and then you choose your chord progressions. You choose 4 of them, but then you are hesitant about the 5th one. That's the second part. So we have a database, and we compare your chord progression with the jazz standards. So if there's a match, you can see that, and it may give you a new idea about what to put, etc. So it's better I can just show it. So as you can see, we don't have any front-end people, but we have a simple design. So I will disconnect the, no, I will just switch this. Okay, so you can change the key here, and you can see all the degrees. But you have another option that you can use chord names. So in classical music, sometimes for theory purposes, students may need to use the degrees actually. So instead of calling this A, they can call the fifth of the D. So that's another option. You can use the Roman numerals or chord names. And we have alterations here. And currently, these are created as I'm pressing them, but we have a little issue about playback. So you will hear the root version, not the altered version. But the other thing is you can drag and drop the chords here. And you can delete them. So let's say you put a basic 251 here. So it matches to our jazz standard dataset. And this, the good part is, this is invariant to key signatures. So you can check it and see that it's actually different than GCF. But it has 251 in the key of B flat major, but this is 251, so it can detect it. And once you are creating more complex things, you can see that, oh, this is the same thing in this Miles Davis standards, etc. So that's one use case, and maybe let's try another one with 1625, because yeah, they are common in jazz. So yeah, currently we have a limited data set for proof of concept. That's why we only have a few things. Yes, this is basically the demo part, and we have only 1.5 slides about the database.
Yeah, I'm just going to briefly introduce the tech stack we use. And for now, it's just a basic web application. So we use Python for backend and the Flask framework for the connections. And we also use the Music 21 library. This is a lab we can first transfer. So this is a lab we can use to build up our database. From the left, we have the music XML file. And then we use this open source library to transfer it into the JSON format. So we got the name and just the chords progression we want. Yeah, and then this is basically the records in our database. And so when the user press the button on the website, it will generate a MIDI file. And then we use Fluid Sync to convert the MIDI file into a playable audio file. So yeah, and we also use a PostgreSQL for database. And maybe we can,
yeah. Okay. Yeah. Well, technically I should be presenting the tech part, but yeah, he did my job. Anyway, thank you. All right, so so far this is a very prototype-ish thing. I mean, the framework that we use is Flask. It can be, not say upgrade, but pretty much upgrade to Django if it's more complicated. For database, we're using Postgres. That is pretty cool. It has a good scalability. For the that's for database management. For the database itself, we are currently using just 10 songs. We can expand it to import a real database that contains like tens of thousands of jazz songs. In those in those files, all the music are in music XML format. That's why we can process it and extract all the chords from it. All right. So for future development, there are quite a few things we can do. We can first add more songs into the database, and we can add a voice recognizer, which means you can it may take some voice input, means the user may hum some voice, and the program will be able to recognize and use it in creation. And so far, as you can see, we're only play the series of the chords that the user selected and stop. We can have more tracks, and some tracks it can loop if the user wants it, and also maybe a generative AI large language model can be used tailored for such jazz creation, can be added on this web page. Yeah, so, but we only have about 1 day to create it, but yeah, that's the future plan for it.
Thank you.
Thank you. Thank you.
Yeah, that's a great job. Also great for guitarists who might just know a few chords, and then you can show them all the songs that they actually know how to play, but didn't know they knew how to play. It's like every Oasis song ever. Great, I'm going to give one more shout out to see if Shrudio are here, but if not, I'll hand it over to JB for the next bit of the presentation, which I think is Q&A, awards.
Yeah, excuse me, join you. Well, I think as far as the live stream is concerned, I think we're going to leave it there. There's a little bit of time that you need to allow us to judge all of this, 15 minutes or so, with the judges that are over here. And so we will reconvene in about 15 minutes, and we'll announce the winners. We'll post them as well on DevPost and post the link on the live stream, so you can discover who's won. But again, the reason we did this hackathon, and the reason we might continue to do those, is because we want super interesting and creative ideas to join the hub. But we want also you to discover that it's a great avenue to create apps that can become a commercial endeavor for you, or just to get your knowledge and your research actually published. So we actually want all of you to win, and yeah, so that's the reason we're here. Thank you very much for all your work. It's been a fantastic 24 hours, and
it's amazing to see what you can create if you're given a plan and not quite enough time. So well done. It's great Leonard Bernstein that said that. 2 things needed for greatness: a plan and not enough time. So yeah, congratulations to all of you again. It's amazing to see what you've done, and I hope that you continue to build on it, and look forward to seeing all your fantastic work in the future, as well as meeting you here. So thank you so much. Give yourself a round of applause, please.